Here are the steps that are going to guide us into understanding what the facade design pattern is. This is going to be so simple, you will not need to look at the code. It is something you have been doing since the moment you downloaded Visual Studio Code. All the code you have written up until today has had a facade at one point or another. We just didn't know what it was. Your HTML, your Express routes, your current calculator app, and so many more. The example we shall look at later in the code will be kept simple, nothing complicated, like a coffee machine or login systems. Just a single class with a single method. So, what is a facade? The facade pattern is a software design pattern commonly used in object-oriented programming. It is an object that serves as a front-facing interface, masking a more complex underlying or structural code. It is a structural design pattern that provides a simplified interface to a library, a framework, or any other complex set of classes. Imagine that you must make your code work with a broad set of objects that belong to a sophisticated library or framework. Ordinarily, you'd need to initialize all of those objects, keep track of dependencies, execute methods in the correct order, and so on. As a result, the business logic of your classes would become tightly coupled to the implementation details of third-party classes, making it hard to comprehend and maintain. The key design principles applied here are encapsulation, information hiding, and separation of concerns. Here is a sample structure of a facade in action. 1. The facade provides convenient access to a particular part of the subsystem's functionality. It knows where to direct the client's request and how to operate all the moving parts. 2. An additional facade class can be created to prevent polluting a single facade with unrelated features that might make it yet another complex structure. Additional facades can be used by both clients and other facades. 3. The complex subsystem consists of dozens of various objects. To make them all do something meaningful, you have to dive deep into the subsystem's implementation details, such as initializing objects in the correct order, and supplying them with data in the proper format. Subsystem classes aren't aware of the facade's existence. They operate within the system and work with each other directly. 4. The client uses the facade instead of calling the subsystem objects directly. 1. Check whether it's possible to provide a simpler interface than what an existing subsystem already provides. You're on the right track if this interface makes the client code independent from many of the subsystem's classes. 2. Declare and implement this interface in a new facade class. The facade should redirect the calls from the client code to appropriate objects of the subsystem. The facade should be responsible for initializing the subsystem and managing its further life cycle unless the client code already does this. 3. To get the full benefit from the pattern, make all the client code communicate with the subsystem only via the facade. Now the client code is protected from any changes in the subsystem code. For example, when a subsystem gets upgraded to a new version, you will only need to modify the code in the facade. 4. If the facade becomes too big, consider extracting part of its behavior to a new refined facade class. Now you can use the facade class and verify the output. In this example, the facade pattern simplifies interaction with a complex library book ordering system. Instead of making your code work with dozens of the framework classes directly, you create a facade class which encapsulates that functionality and hides it from the rest of the code. This structure also helps you to minimize the effort of upgrading to future versions of the framework, or replacing it with another one. The only thing you'd need to change in your app would be the implementation of the Facade's methods. Continuing on with our library example. Imagine you've been asked to design a system that returns list of books according to their genre. You will probably find out what kind books this library offers, and then go on to write up functions that return those books. To get a list of each category, you have to call a specific function. In our code example, we only have 4 categories: adventure, horror, non-fiction, and fiction. There is a very high probability of increasing our category. But now, here is a problem: the client doesn't know what categories are available, nor does he know how to access them. Does he have to guess what functions call for what category? How many functions does he or she need to call to get the desired outcome? This is where a Facade design pattern would be useful. The first thing we need to do is visualize how our library should look like. So let's create a UML diagram. Our category functions will need an interface, so let's give them one. We can now introduce a Facade to be the liaison between our system and the client. The client does not need to know how the app works, but as long as the list of books in his or her genre is returned. Now that we know how to fix our app, let's go and fix it. This is how our app currently looks like. This is not good. So, the first thing we need to do is create an interface. We shall call it book genre. Next, we change our functions into classes that implement the book genre interface. So now our app has changed from this to this. The Facade does not necessarily need an interface, but since we are sticking to object-oriented programming principles, let's give it one anyway. We shall call it iLibrary. It shall have 2 methods, one for getting the book genre, and the other for details on the client who requested for the information. Now that we have an interface, let's create our Facade. With the constructor, all we need is information of the person requesting our books, and the genre they are trying to find information about. Given that our client will only deal with the Facade, we add methods he will use to interact with the app. We also add a setter for when he needs to change the book genre. Our app is finished, and it is now ready for testing. This is our final result. From top we have our interfaces. Then our categories. And finally the Facade library. Now let's go on to testing. Let's initialize our new object library with parameters, the user, Pamela, and what kind of genre she wants information on, non-fiction. Let's log into the console the getGenre method and see what results we get. First we compile, then we run the script. Wow! Would you look at that? It is running. Oh, look, they even have a book on design patterns. Professor Jackson would be proud. So, when do we use the pattern? 1. Use the Facade pattern when you need to have a limited, but a straightforward interface to a complex subsystem. 2. Use the Facade when you want to structure a subsystem into layers. This approach looks very similar to the mediator pattern. The readability and usability of a software library, by masking interaction with more complex components behind a single, and often simplified, API. It provides a context-specific interface to more generic functionality, complete with context-specific input validation. It serves as a launching point for a broader refactor of monolithic or tightly coupled systems in favor of more loosely coupled code. Thank you for sticking around. I have been your host, Sonia, an AI designed by Group 2. Special thanks to my creators, Albert, Pamela, Edwin, and John. For more details about the facade design pattern, check out the slides in the Google Classroom for more examples and use case scenarios.